Good morning. Today we were going to discuss about point groups. Let us look down the different types of point groups. The first one is non-axial point groups, or they are no rotation point groups. And examples are C1, CS, Ci. It does not contain any axis of rotation, and they are non-axial point groups. Then the next point groups are cyclic or rotation point groups. That is, it will contain a rotational axis, and they are commonly named as Cn, Cnv, Cnh, Sn, etc. Or we can say that they must contain, or they will contain, a definite rotational axis or definite axis of rotation, and n will be that number equal to, that is, the 360 divided by the axis of rotation. That will be the value of n. For example, if we are rotating around 180 degree of axis, then the n value will be equal to 360 divided by 180. Or we can say that n is equal to 360 divided by theta. And the next one is dihedral point groups. That is, there will be some sigma reflection planes that is perpendicular to the C2 axis or 180 degree rotation, and they are dn, dnd, dnh. Then the next one is polyhedral or higher order point groups, and they are T, th, tetrahedral, all are the forms of tetrahedral point groups. Then O, OH, octahedral point groups, I and icosahedral. And we have two more point groups, that is linear, that belongs to linear, C infinity V and D infinity H. So we can look at the chart given below and find out the different types of point groups. Generally, non-axial groups, they are C1, CS, Ci. Cn groups, C2, C3, C4, C5, C6, C7, C8. And if C1 is present, we can say that it contains only 360 degree of rotation. CS, it will contain only one improper axis of rotation, and Ci will contain only one inversion center. Cn groups, that is depending on the angle of rotation theta, they are classified as C2, C3, C4, C5, etc. Then Dn groups, as dihedral groups, they can be D2, D3, D4, D5, etc. depending on the angle of rotation. And Cnv groups, and it also depends on the number of sigma v planes or vertical mirror planes and the axis of rotation. And CNH groups, they also dihedral planes, dihedral point groups. It will contain a sigma h group or sigma h horizontal plane of reflection. Then we have DNH groups, it can be D2H, D3H, D4H, etc. DND groups, D2D, D3D, D4D, etc. And SN groups, S2, S4, S6, S8. There are even numbers only present. Cubic groups, T, TH, TD, O, OH, I, IH. And linear groups, C infinity V and D infinity H. So these are the common point groups present. Then the next is how to find out the point group. How we will find out the point group of a molecule. And the first question is to find out whether the molecule, it is linear. Okay, if it is linear, it can be C infinity V or D infinity H. If the molecule is linear, it can be C infinity V or D infinity H depending upon the inversion center present or sigma V present. Then the next one is there more than one axis of symmetry of order greater than 2? If it contains more than one axis of symmetry, that is, if it contains C4 axis, C5 axis, C6 axis, etc., then if the answer is yes, then the symmetry is a special case, or we can say that it belongs to the higher order point groups, that is tetrahedral, octahedral and icosahedral. Or we can take, for the simplification of calculation, we can take the lower symmetry point groups, that is T, O and I. Then if it does not contains more than one axis of symmetry of order greater than 2, that is, if the answer is no, Then check out, is there at least one axis of rotation Cn? This, check whether if it contains axis of rotation Cn. And if it does not contain such an axis, it does not contain an axis of rotation, or only 360 degree of rotation is possible, then check whether it contains, is there a rotation or reflection axis N. If it contains a reflection axis N, then the point group will be Sn. If it does not contain a rotation or reflection axis, then check whether it is having a plane of symmetry sigma. If it is having a sigma plane, then the point group will be Cs. And if it does not contain any symmetry, plane of symmetry sigma, then check whether it contains the center of inversion I. If it contains such a center of inversion I, then the point group will be Ci. And if it does not contain a center of symmetry I, then the point group will be equal to C1. Okay. And if it contains one axis of rotation with Cn, this if it contains either C2, C3, etc. C4 case we have taken here, it will be higher order. And if it contains C1 or C2, C1, C2 or C3, the answer is yes. Then check whether are there n C2 axis perpendicular to the principal axis Cn. Check whether it contains n C2 axis, whereas n is the value equal to 360 by theta. Does it contains n C2 axis perpendicular to the principal axis Cn? And if it does not contain such a plane, such an axis, then check whether is there plane of symmetry sigma perpendicular to the principal axis. Check whether it contains a sigma perpendicular to the or sigma h plane, that is planar plane or horizontal plane. If it contains such a horizontal plane, then the point group will be CNH. If it does not contain such a plane, then check whether are there n planes of symmetry parallel to the principal axis. Check whether it contains symmetry, sigma v planes, n sigma v planes. If it contains n sigma v planes, then the point group will be CNV. For example, in the case of water, it contains 2 sigma v planes, then the point group will be C2V. In the case of ammonia, it contains a C3 axis, but does not contain any C2 axis, n C2 axis perpendicular to the principal axis. And it does not contain a sigma h plane, and it contains 3 sigma v planes. Hence, the point group will be equal to CNV. And if the answer is no, that is, it does not contain any n sigma v planes, then the point group will be Cn. And if it contains n C2 axis perpendicular to the principal axis Cn, the answer is S. Check whether a sigma h plane is present. Okay, that is the plane perpendicular to the principal axis is present. If the answer is S, then the point group will be DNH. For example, we can take the case of BF3 molecule. It contains a C3 axis. It has 3 C2 axis perpendicular to C3. And we can see that it also contains a sigma h plane. Then the point group is DNH. Okay, and it contains n C2 axis perpendicular to the principal axis N and does not contain any sigma h plane. Then check whether are there n planes of symmetry parallel to the principal axis. Check whether it contains n sigma v planes. If it contains n sigma v planes, then the point group will be DNV. And if it does not contain any planes of symmetry, then the point group will be DN. Okay, here 2 examples are given. That is one for C1 and the one for Ci. Here CHFClBr, this derivative of methane, bromochlorofluoromethane. All the atoms attached to the carbon atom are different, and it contains only 360 degree of rotation, and the point group is C1. And here this one, it contains only one inversion center, and the point group is Ci, and they all are low symmetry point groups. And this is a flow chart. That is a conclusion, or it is a crispy form of the discussed matter. That is first one, linear. If it is S, check whether it contains I. If it is S, it contains an inversion center, then the point group will be D infinity H. If it does not contain any inversion center, C infinity V. And if it is not linear, then check whether and check whether it contains 2Cn greater than or equal to n greater than or equal to 2. If it is S, check whether I. If it contains I, check whether it contains C5. If it is having C5, then it will be icosahedral. Not C5, then it will be octahedral. And if it contains an I, if it does not contain an I, then the point group will be tetrahedral. And if it contains more than n greater than, rotation axis with n greater than 2, does not contain, then check whether it contains any Cn. If it is S, select the highest Cn. Then find out whether NC2 perpendicular to Cn. If the answer is S, check whether it contains sigma H. If it contains sigma H, then the point group will be DNH. If it does not contain any sigma H, then check whether it contains N sigma D. If the answer is yes, then the point group will be DND. If the answer is no, then the point group will be DN. And if it does not contain NC2 perpendicular to Cn, then the point group will be sigma H. Now check whether it contains sigma H. If it is S, then the point group will be CNH. And if it does not contain any sigma H, check whether it contains N sigma V. If the answer is yes, then point group will be CNV. And the answer is no, check whether it contains S2N. And if it contains S2N, then the point group will be S2N, or then the point group will be CN. And here, if it does not contain principal axis with n greater than 2, and check whether it contains Cn, and it will not contain any rotation axis, then check whether it contains any sigma planes or reflection planes. If it contains a reflection plane, then the point group will be CS, and if it does not contain any, then check whether it contains a point of inversion, center of inversion I. If the answer is yes, then the point group will be CI. If the answer is no, then the point group will be equal to C1. Then, here is an example to how to find out the point group symmetry. The molecule is BF3. So, first find out whether the molecule is linear. No. And does the molecule have tetrahedral, octahedral or icosahedral symmetry? No. Then, find out whether it contains any Cn axis. Yes, it contains C3 axis. And it contains 3 C2 axis. That is, contains n C2 axis perpendicular to the principal axis. And find out whether it contains a sigma H plane. Yes, it contains a sigma H plane. So, we can say that the BF3 molecule has D3H symmetry. Here is given an example of C1 point group. That is all attached atoms are different. It has only 360 degree rotation and it belongs to the C1 point group. Then CNV molecules, water. It has C2 axis, then 2 sigma V planes. Then the point group is C2V. Ammonia, it contains C3 axis and it has 3 sigma V planes. And hence the point group will be C3V. Then the next example is C4V. 1-adyl tetrafluoride. C4 axis lies in 4 mirror planes, 4 sigma V planes. Thank you.